So the next thing we're going to talk about is end behavior as far as sort of building towards graphing a polynomial. In general, the type of shape we're going to get is sort of a roller coaster type shape. So we will get roller coaster type shape from our polynomial graphs. Right, meaning that they're going to be doing up and down type behavior. In general, the higher the degree, right, the sort of bigger the polynomial is, the more twists and turns it'll take, the more potential sort of turns from like up to down it can do. The simpler they are, the fewer turns they're going to do. So something like our sort of classic quadratic, ax squared plus bx plus c, right, is going to give us some sort of parabola, which is either sort of an up u, or I'll squeeze in, doesn't look quite so good, or a down u, right? This would be sort of the most complex, so maybe you're getting up to degree 4 or 5 here. This is maybe somewhere in the middle. Maybe this is degree 4 or something. So what we're going to do to sort of continue trying to sort of find enough information to be able to make one of these graphs, to make a decent sketch of what this is going to look like, we're going to kind of work our way from the outside in. And so the first stop here is we're going to talk about end behavior. So end behavior is like, what does the graph do as you get like further and further out to the left or to the right? So maybe we can be a little bit more specific about that. So this is sort of what is the like y behavior as the x's go to positive infinity, which is to the right, or negative infinity, which is to the left, right? So as your x values go out to the left and out to the right, what is your graph doing? Is your graph, right, it could be going up to positive infinity, it could be going down in either direction. So you kind of have, the options here are the y's, go to positive infinity, right? They go up, or they go to negative infinity, which means they're heading down. And so we need to just sort of combine these two ideas, right? So moving to the left, moving to the right, and either sort of moving up to positive infinity or moving down to negative infinity. Get two directions and sort of two options to go. This is going to end up giving us essentially 4 different cases for end behavior. There's like 4 different possible outcomes. We're going to use our leading term, meaning we're going to use the degree and our leading coefficient. So if our generic polynomial f of x, right, an, x to the n, an minus 1, xn minus 1, plus yada yada yada, a2x squared, a1x plus a0. All the action for the end behavior is coming from our first term, that leading term. So we're getting a leading coefficient from there and the degree from there, just like we were doing in the last video. So let's break this down into 2 cases. What we're going to be looking at is whether the degree of the polynomial is even or odd, and we're going to be looking at whether the leading coefficient is positive or negative. So 4 cases for end behavior. And let's do this. How are we going to divide this up? So let's say degree is even. We'll do this sort of as like a branching kind of exercise. Versus degree is odd. And then this is going to split, right, into 2 different cases, because if your degree is even from there, then you're going to have leading term is positive versus your leading term is negative, positive or negative, and then the same split for when your degree is odd. Your leading term is positive or your leading term is negative. So we get kind of cases 1, 2, 3, and 4. So an even power, an even degree on your highest power, and a positive coefficient. Let's just sort of go through these one at a time. So if the power is even, something like x squared or x to the 4 or x to the 6, you guys know what even numbers are, 2, 4, 6, 8, 10, right? And so on. So if you have an even degree and then your leading coefficient is positive, so any positive number or positive 1, right? So positive x squared, positive x to the 4 is a positive 1, right? With an even degree. The end behavior, what you're going to get, I'll sort of draw it with arrows first. So the end behavior that you get is increasing to the left and increasing to the right. So up to positive infinity in both directions. So as you go out further to the left and to the right, eventually what happens is you start to increase without bound. You go up to positive infinity. What we would say here is it rises to the left and it rises to the right. So rises to the left, rises to the right. So up to positive infinity in both directions. If the degree is even and then the coefficient is negative, what happens is you get this same kind of like matching behavior. Both directions are going to sort of do the same thing, but now instead of increasing and going to positive infinity, your end behavior is going to be sort of an infinite decrease. It's going to drop down to negative infinity. So what we get now is sort of a drop or a fall to the left and then a fall to the right. So we would say falls to the left, falls to the right. Keep these guys a little more separated. So case 1, case 2. If the degree is odd, what happens now is instead of your left and right behavior agreeing and moving in the same direction, they disagree and they move in opposite directions. So either one falls and the other rises, or sort of vice versa. So if the degree is odd, right, if the highest power is 1, 3, 5, 7, and so on, and then the coefficient is positive, what's going to happen there is you're going to get a drop to the left and you're going to get a rise to the right. So this falls to the left, rises to the right. So it's sort of a disagreeing thing, disagreeing behavior. So falls to the left, rises to the right. By sort of process of elimination, you can probably guess the last option here, the only thing that's really left over as far as what the options are, is if our coefficient is negative and the degree is odd, so 1, 3, 5, 7, yada, 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 what's going to happen is we're going to rise to the left and we're going to drop to the right. So rises to the left, falls to the right. So these are kind of the results. These are the options. This is what can happen. let's just take a couple minutes and just look at a few polynomials and sort of see if we can identify what's going to happen. I'll try to keep this visible. We'll do some polynomial work underneath. There we go. That's reasonable. Is it? We'll try to make it work. So we could kind of throw any old numbers at it. So let's do end behavior examples. So maybe f of x is negative 5 x to the 4 minus 3x squared plus 7x. All I care about, again, is this like first term. This is the one where I'm getting all this end behavior information from. So the degree is 4, is even, right? And then my leading coefficient is negative 5, is less than 0. So my degree is even, and my coefficient is negative. So which of our cases? So even is here, right? And then our coefficient is negative. That means we're in the second case. So that's going to be false to the left and false to the right. This isn't telling us necessarily anything about the actual sort of up and down process like in between, right? This is only telling us what happens at the very end. If I was going to kind of visualize it, right, it would be sort of a down and a down. Some sort of up and down happening in between, or we could say, right, falls to the left, falls to the right. So negative 5 x to the 4. The other terms, right, they're there. They're going to have an impact on what happens in the middle. But as far as getting like way out to the ends of our graph, the only thing that's going to have an impact is that biggest term that really just sort of takes over once we get further out to the ends. Let me do one that's kind of pre-factored so we can see what that would look like. We'll take one apart and get something out of it. So maybe g of x is like 3x squared, x minus 4 quantity squared, and then this is like 2x plus 5 or something, right? So all I care about is my leading term. So I'm going to get that, right, by sort of expanding this out partially. I'm going to take 2x, I'm going to take x squared, and I'm going to take 3x squared. So my leading term is going to be 3x squared times x squared times 2x. So this is positive 6x to the 5. Right? So that's my leading term. That means then my degree is 5, which is odd. My leading coefficient is positive 6, emphasis on the positive, right? Greater than 0. So what case is that? So degree is odd. My coefficient is positive, so that's going to be case number 3. So that's going to be falling to the left and then rising to the right. So that's the basics of it. Obviously, like, you can do a few more examples. You can really throw any numbers you want at this and sort of see this different behavior. So it only affects this stuff out on the very ends. Again, we're kind of building our graphs from the sort of outside and working our way towards the middle.